Now, I will take you to some more problems related to these directions, and then I will discuss about logical Venn diagrams, and once again we will review some of the problems related to all the aspects that we have studied. So, quickly this next problem on directions. One day Ravi left home, cycled 10 kilometers southwards, turned right and cycled 5 kilometers, turned right again and cycled 10 kilometers, turned left, cycled 10 kilometers. How many kilometers he have to cycle to reach his home back? So, the problem is Ravi left home, ikkada cycled 10 kilometers south from wherever initial position he is moving towards south, turned left and cycled 5 kilometers, turned right again, cycled 10 kilometers, turned left, cycled 10 kilometers. How many kilometers will he have to cycle to reach his home? So, wherever final position he has reached, from there what is the distance between initial position and final position? This is what you will have to find out. So, try and draw a small little diagram, so that you would understand how the flow goes, and from there geometrically you can view the distance between the starting point, initial point, and then the end point. So, let us start with drawing this diagram. How does it go about? So, Ravi, supposing I assume that his initial position is at A, towards south he cycled 10 meters. From there he took a turn and then cycled 5 meters. Then again he took a turn and then cycled 10 meters. From there he took left and reached, cycling 10 meters he reached point E. So, he started at A, now he is at E. We need to calculate the distance between A and E. So, see the problem once again. Ravi left home, cycled 10 kilometers or meters, the problem solution says meters. So, 10 meters southwards, supposing he has started here, he has reached south, turn to right. You imagine that you are standing on the other way around, your right would be here. So, from here he has taken a turn right, cycled 5 kilometers, turned right again, that means he went towards north distance, cycled 10 kilometers. From there he has taken a turn left. So, this is how the diagram would be. Starting at A, he cycled 10 meters or 10 kilometers towards south. From there he has taken a right turn, cycled 5 kilometers. This is the turn he has taken, cycled 5 kilometers. Then he reaches C. From there he has taken a right turn. He is reaching D after cycling for 10 kilometers. From D he has taken a left turn, he is reaching E. So, now what is that we will have to find out? How much distance he has to travel so as to reach his home back. This is the initial position, this is the final position he would be, this distance is what you should find out. Once you draw the diagram, the solution would be very, very easy. How does this look like? This look like a extended square. So, now here E to D is 10 kilometers, and if you look here, so Ravi starts from home A, moves 10 kilometers south up to B, turns right 5 kilometers up to C, turns right again and moves 10 kilometers up to D, finally turns left and moves 10 kilometers up to E. So, his distance from initial position to E, AE, this is what we will have to find out. If you want to find out his position from AE, it is in the diagram, if you look at it is AD plus DE. Shall I show you the diagram again? It is AD, this distance, plus DE. So, how much is DE? DE is 10 kilometers. How much is AD? It is same as BC. From the diagram we can identify that this looks like a rectangle. So, these two sides are equal, these two sides would be equal. So, AD is going to be 5 kilometers again. So, that is what we are writing, AD plus DE is same as BC plus DE, that is 5 plus 10, 15 kilometers. So, this is how he is going to travel to reach his home. So, quickly I will take you to the next aspect, which is going to be logical Venn diagrams. So, when logical Venn diagrams are given, we are supposed to analyze the items that are given in the groups, and then illustrations should be done diagrammatically. Either diagrams will be given, we need to draw conclusions from the diagrams, or if some kind of description relationship between groups is given, we need to draw the diagrams and give the solution. So, all these Venn diagrams can be put into 10 types. If you understand these 10 types, then it is as good as you have understood all problems on Venn diagrams. So, the first type is items belonging to 3 different groups, like say doctors, engineers, lawyers. They are 3 different groups, there is nothing common in them. So, the diagram would look like this: doctors is separate, engineers is separate, and lawyers is separate. So, the first kind where all these 3 are apart, they are drawn apart, because items belonging to 3 different groups. So, the second kind is one item belongs to a class of second and the second belongs to a class of third. Say like for example, you are looking at this is your hours, in this hours you have minutes and in this minutes you have seconds. So, the diagram is like this: you have an hours Venn diagram, inside the hours you have minutes, completely a subset of this, and inside the minutes you have seconds, which is again the subset of the superset hours, minutes. So, one item belongs to the class, one item belongs to the class of second item. So, minutes seconds belongs to the class of minutes, minutes belong to the class of hours. Then this is how the diagram looks like. 2 separate items belonging to the class of third. So, these are 2 separate items, there is no intersection between these two are separate, but these 2 belong to a common third class of items. So, this is how your diagram looks like. Say for example, these are tables, these are chairs, then together they belong to the main set, which is the furniture. So, in furniture you have so many other items, but definitely there are tables and there are chairs. So, this is how 2 separate items belonging to a class of third item, this is how your diagram looks like. So, you have table, chairs and then part of the furniture. 2 items belonging to the class of third item such that each of these 2 groups have a common relationship. Unlike tables and chairs, here there is a intersection, some of the items of this type can be this, some of the items of this type can be this, but again these 2 belong to a third set. Say for example, you take this as men, men is your superset, then you have fathers, you have brothers. So, some of the fathers can be brothers of some other people, some of the brothers can be fathers of some other people, together they all are contained in the set of men. So, this is another kind of Venn diagram which is drawn to represent where 2 items belong to the class of third such that each of these 2 groups have common relationship. So, the next one is 2 items are partly related to the third, but are mutually independent, like dogs, pets, cats. So, you can have some of the dogs as pets, some of the cats as pets, but you cannot see any relationship between dog and cats. Dogs are dogs, cats are cats. So, that is what two items are partly related to a third item. So, here the third item is your pets, then dogs can be part of pets, cats also can be part of pets. So, this is how your diagram looks like. Then you have another kind of a thing, three items are partly related to each other. So, there is no independence here, there is a kind of relationship that exists between all the three items. Like say you have one is clerks, government servants, educated people. So, educated people can be clerks, educated people can be government servants, clerks can be government servants, and then there is a common intersection which speaks about clerks, educated people who are clerks and also government clerks. So, this is how the diagram looks like when you have three items partly related to each other. One is not completely subset of the other, but they are partly related. So, clerks, government servants, educated persons, if you take, this is how your diagram looks like. So, the next kind is if one item belongs to the class of second, while the third item is entirely different. Like I have taken an example here, you have this is the superset which speaks about Asians. So, in this Asians, all Indians are Asians. So, they are completely in the set of Asians. Whereas, if you look at Europeans, there is no link between Europeans and Asians. So, one item, if one item belongs to the class of second item, completely Indians are all contained in Asians, while the third is entirely different. So, Indians, Asians and Europeans, if you want to represent, this is how your diagram looks like. This set is Indians, this set is Asians and these are Europeans. So, the next kind, one item belongs to the class of second and the third is partly related to these two. So, one item belongs to the second and the third is partly related to these two, like female, mothers, doctors. So, one item belongs to the class of second, all mothers are female, it completely belongs to the second, but then partly related to the third. So, the third one is there which is partly related here, doctors. So, females, these are all mothers, this is it is completely contained in the set females, and then these two have some intersection with doctors, that is you can have female doctors, you can have female mothers who are doctors. So, this is how your Venn diagram looks like when one item belongs to the class of second and the third is partly related to these two. Next one is one item belongs to the class of second and the third is partly related to the second, but not the main one. So, like male, father, children. So, if you are looking at this is your male set, then fathers are completely male persons, they are in this and partly they are related to children, that means children can be male. So, this is an example, you have male set is this, in this the second class is completely contained here, fathers, and then you have a third class which is partly related to the first one. So, it looks like this, some children can be male. The last one now, two items are partly related to each other and the third is entirely different from the two, like you have professor, author, illiterate, that is few professors can be authors. So, this is professor, this is author, there can be intersection, authors can be professors, professors can be authors, you have intersection, whereas you have a third type which speaks about illiterate people, illiterate cannot be professors and authors. So, these are the 10 different diagrams, Venn diagrams. Using these you will be able to solve any logical problem using your Venn diagrams.